Hello to all my viewers. This is Dr. Dhaval Maheta, and today we will understand how to run logistic regression by splitting the data in nine. So, in case of logistic regression analysis, we are having one dependent variable which is categorical. The example of it is patient having the heart disease or not having the heart disease. The customer will purchase our product or not purchase our product. There can be many independent variables, and these independent variables can be in continuous or categorical scale. In this tutorial, we will split the data into training and testing dataset. Moreover, in this tutorial, we will also discuss the confusion matrix which will be generated. Now, what is this confusion matrix? We will see later on. First of all, let's go on KNIME Analytics platform. I'll activate input output from here, CSV reader node. I'm using CSV reader node as my dataset is in CSV format. Double click on it, browse. I'll browse my dataset. I'll request all my viewers to kindly refer my previous video to understand the flow of this lecture series. I'll connect Heart 1 with this. Press open, click OK. Right click on it and execute. Again right click on it and activate the file table. So we have already discussed in previous video that our dependent variable is heart disease, yes or no, which we want to classify on the basis of age, resting blood pressure, cholesterol, and maximum hours of exercise. As they are on different scales, we are using the normalizer for it. So I'll activate the normalizer here. Again, right click on it, configure. I'll remove old peak and fasting blood sugar. Three types of normalizations we have discussed earlier: minimum, maximum normalization, z-score normalization, normalization by decimal scale. Here I'm going to use a mean max normalization. Click OK. Right click on it and execute. Now this data, we want to divide it into training and testing data set. And therefore I'll activate partitioning from here. Double click on it. Connect the node, right click on it and configure. Activate from here 80%. It means that 80% data set will be used for training purpose and 20% will be used for testing. Activate draw randomly from here, click OK. Right click on it and execute. Again, right click on it and you will be able to see the first partition in which 80% data is used for training data. This is 80%, 734. Total data set is, let me show you the total data set. It is 980. If you take 80% of it, it will generate the first table, first partition, which is used for training data set. Now, right click on it and see the second partition where 20% data set is there. The next thing which I'll do is I'll activate the logistic learner from here. Right click on it, configure. Heart disease. Reference category will be used as no. All these concepts we have already discussed in my previous videos. I'll remove all of them. I will only include those variables which have been normalized. Age, then resting blood pressure, then cholesterol, and maximum hours of exercise. Click OK. Right click on it and execute. Now again right click on it and see the coefficient and statistics. The interpretation of this table also we have seen in the previous video. Let me make you recall that the p-value of all these variables should be less than 0.05, and the equation which will form, it will be formed on the basis of this coefficients of this variable. So the equation is log of odd of heart disease is equal to the constant into 1.699 times into age plus 1.59 into resting blood pressure minus 2.241 into cholesterol minus 4.207 into maximum hours of exercise. So this is our model, right? This is our model. Uh, Now, on the basis of this learner, I want to do the prediction for the remaining 20% data set. So I'll activate logistic regression predictor. I'll disconnect from here. So the model will come from this learner to the predictor, but the data set, the second partition, which is having 20% data, a complete, you can say this 20% data set is never used to for the learner purpose. I am connecting it to the predictor, and I want to see is it able to predict the observations properly or not. Right click on it and configure. Click on custom prediction column and append columns with the predicted probabilities. Click OK. Let me check this configure, and it should be on no reference category. We are keeping it no. Okay. Again, right click on it and execute. Right click on it and click on predicted data. Now, this is our actual data set, and this is a prediction done by our logistic regression model. So in the first case, the actual data is, now it is quite likely possible that sometimes the original observation is no and the model predicts yes, or it can be reverse also. The original observation is yes and the model predicts no. Now, what is our success? Our success is that the patient is not having the heart disease and the prediction of the model is also no. So, no and no, this is our success. Similarly, a patient is having a heart disease and our model also predicts it correctly, yes, then this is our success. Now, on the basis of this, a confusion matrix is generated. I will give you a very simple example of this confusion matrix. A patient is having a COVID, that is COVID or normal, and COVID kits are used to detect the patient is having a COVID or not. So, patient was having a COVID and the kit also detected it. So 50 such cases are there. This is our success. The kit is working correctly. Similarly, a person was normal and the kit also detected it. Yes, he is normal. So 114 such cases are there in which the COVID kit is successful. But the problem can arise when the patient is normal and COVID kit detects that patient is having a COVID. This is misclassification. Similarly, it can also happen that a person was having a COVID, but the kit predicted normal. So 22 such cases are there. So 22 plus 6 are misclassified cases. Now, on the basis of this, some statistics are generated in machine learning. The first one is positive to positive, true positive, which is essential or rather a success for us. Negative to negative, true negative, it is also a success for us. What is the overall accuracy for our model? True positive plus true negative means 50 plus 114 divided by the total observations. So total observation is 50 plus 114 plus 22 plus 6. So that gives me the classification accuracy. Then there is a sensitivity. Total, sorry, true, true positive, TP, divided by true positive plus false negative. This one is sensitivity. Then comes the specificity. True negative divided by true negative plus false positive. This one. Then comes the precision. True positive divided by true positive plus false positive. That is precision. And a negative predicted value is true negative divided by false negative plus true negative. So let us say one example is that true positive is 2894 and true negative is 11750 and false negative is 994. Misclassified cases is 994 and 643. So what is the classification accuracy for us? 2894 plus 11750 divided by the total observations. The total observation is 1, 2, 3, 4. So we get 0.899. That is a classification accuracy score for us. So it will also generate the area under the curve, which we will see in the next video. So at present, let us go back in KNIME Analytics platform to see that is our classification, or rather our model is working correctly or not. So for this, I will activate scorer from here. Again, right click on it and configure. Now activate here the hard disease, the original data, which we want to compare with the predicted hard disease. Click OK, right click on it and execute. Again, right click on it and see the confusion matrix. Now you can see here 75 are such cases in which a patient was having the heart disease and the model also predicted. So 75 correct classified cases. 53 such cases are there in which the patient was not having the heart disease and the model also predicted no. But the misclassification happened here. A patient was not having the heart disease, model predicted yes. And here a patient was having the heart disease and the model predicted no. Now, on the basis of the confusion matrix, some statistics are generated which are known as the accuracy statistics. You can see here. Now, let's do the interpretation of it. The first one is the classification accuracy, which is 0.696. Let me go in the interpretation table. I have already explained all these concepts in my previous video. The first one, the classic overall accuracy. So here our overall accuracy is how much? It is 0.696. It's quite good. 0.696, which suggests that the model has predicted the outcome approximately 69.6 percentage of the cases. So this is the overall accuracy. Then comes the recall. Recall is true positive divided by true positive plus false negative. We have already discussed this concept. Let me check where the recall is. So here I will pick up the recall of yes, and it is 0.743. That's right, the interpretation 0.743. So 0.73 indicates that the model correctly identified 74.3% of the positive cases. In other words, out of the actual positive cases in the data set, the model identified 74.3 percentage of them as positive. This is recall. Next comes the precision. Let's see its value. Again, precision. Precision value for yes is 0.714. So precision is true positive divided by true positive plus false positive. How much was the value? It was zero point 0.7. Yeah, I'll write down here. So 0.714 indicates that out of all the cases, the model predicted as positive 71.4 percentage of them actually positive. In other words, the model correctly identified 71.4 percentage of the predicted positive cases as true positive, which is quite good. Then comes the specificity, or sorry, sensitivity. Sensitivity is true positive divided by true positive plus false negative. Let me see its number. Sensitivity, how much is it? 0.743. It is also quite good. So let me replace this 0.743. So sensitivity is true positive divided by true positive plus false negative. A sensitivity score of 0.74 indicates that a model correctly identified 74.3 percentage of the positive cases. In other words, out of the actual positive cases in the data sets, the model correctly identified 74.3 percentage of them as positive. Okay. Now, next comes the specificity. Specificity is true negative divided by true negative plus false positive. Now, where the value is? of specificity, it is 0.639. Okay, I'll write down here 0.639 indicates that model identified 63.9% of the negative cases. In other words, out of the actual negative cases in the data set, the model identified 63.9% of them as negative. Next comes the F1 score. So F1 score is 2 into precision into recall divided by precision plus recall. So what is its value? Let us check. F1 score, it is 0.728, quite good. So 0.728 indicates that the model has a good balance between precision and recall and is currently identifying the positive cases without without falsely classifying negative cases as positive. A F1 score of 1 represents the perfect precision and recall, while a score of 0 represents the worst possible performance. Therefore, a score of 0.72 indicates the model performance is relatively good. Now, let us try to see this on the donut chart, that how much classification accuracy we have achieved. Let me go back here and I'll activate pie chart from here. Let me break this. So this is used. This will generate the donut chart without the model. First of all, configure heart disease, yes or no. So we will consider. So make sure occurrence count is on. Heart disease, you will activate heart disease and make sure generate image port is also on. Generate plot options, in that activate the percentage here. Click OK. Right click on it. Again, execute and see the pie chart image. You will get 55% patients are having heart disease, yes, and 45% are not having it. Right, so this is the raw data. Now, let us use the same donut chart for our model. I'll right click and create a copy of it. And let me connect this to the predictor model. Again, right click on it, configure, heart disease, occurrence count, generate image, generate plot options, percentage is on, click OK, right click on it and execute. Again, right click on it and see the pie chart image. So you can see it is 55% and 45%. More or less, it is nearer to the original raw data. So this is a way you can run logistic regression by splitting the data set in KNIME. For more videos on KNIME, kindly subscribe to my channel. You can get linked with me on Twitter and LinkedIn. Please don't forget to subscribe the channel and press the like button. You can see my playlist in which I already uploaded many videos on KNIME.